Hello, my name is William Iwasco, and I'm a lead forecaster in the Lubbock, Texas office. This presentation will discuss the Analyze and Adjust step of ForecastBuilder. Now, ForecastBuilder has finished populating the base grids for us, and you'll notice that this GUI will pop up. These buttons will help you to ensure your base grids are as you want them or to assist you in making any necessary changes. Now, we'll go into details on what each button does on the following slides. Note, for those offices utilizing snow level grids, we'll describe the additional buttons found on that GUI at the end of this video. But before you select any buttons, you'll want to spend some time looking through the grids that have just populated and make any changes that you deem necessary. While it might be tempting to just select Save and Continue, spending a little time analyzing your grids at this point could save you quite a bit of time in the next steps of ForecastBuilder. Now you may be wondering when you should make changes to the initial grids. Well, the simple answer is anytime your meteorological reasoning differs from the initial grids that were populated. Targets of opportunity and known model biases are an easy place to start with making grid changes. If you find yourself making the same change multiple times, make sure this information is being passed back to the model developers so that they can attempt to correct the bias in future upgrades. Obviously, sometimes a change to a grid could be highly impactful to our end users, and these should be the changes that we focus on. For example, worrying about changing a max temperature grid from 68 to 71 probably won't impact our partners all that much, but changing it from 30 to 33 degrees could have major impacts on them. But before making any changes to the grids, you'll have to coordinate these changes with any surrounding office that would be impacted by having a meteorological discussion on why these changes are needed with them. Remember, people that use our forecasts don't have the same boundaries that our offices do, and discontinuity between offices can lead to a lack of confidence in our agency as a whole. In the end, though, each region has differing criteria on when, where, and how to make changes to the initial grids, and you should be familiar with and follow these guidelines. Now getting to the nitty-gritty of the GUI, under the Analyze and Preview p-type sections, you'll see two buttons for Weather Preview and Snow Amount Preview. These buttons are both optional and do exactly what they say, providing you with a quick preview of the expected weather types, or a look at the snow amount based on the initial NBM precipitation types. If you select either of these, temporary grids will populate at the bottom of GFE, allowing you to cycle through the grids. Under the Adjust section, you'll see four options. The first two deal with checking and adjusting the hourly temperature grids against the max and min temperature grids. The Derive Hourly T from Max Min button will adjust the hourly temperature grids to ensure at least one hourly grid is within 1 degree of your max and min grids. The Check Max T Min T T Consistency button will be run once you select Save and Continue, but you can also choose to select it prior to moving on to determine if any changes may be required. Note, for more details on both of these tools, watch the Deriving Hourly Temperature and Relative Humidity module. The Recalculate Pop from Pop 12 button is an easy way to maintain the spatial distribution of your floating pop grids, but to shrink or stretch the magnitudes of them if you determine that the values need to be changed. This is especially handy if you have hourly pop grids, as you only have to adjust the one Pop 12 grid rather than all 12 hourly pop grids. The last tool is Add Smoke to Sky from Her. This is an easy way to increase your sky grid if you're expecting a layer of opaque smoke to move over your forecast area. As a reminder, NWS Directive 10-201 does state that sky cover is, quote, the expected amount of opaque clouds or other opaque phenomenon that might be aloft, end quote. Once you are finished making the necessary changes to the grids, it's time to move on to the next step of ForecastBuilder by selecting the Save and Continue button. For more details on the Recalculate Pop from Pop 12 and Add Smoke to Sky from Her buttons, please continue on to the next slides. Additionally, if your office utilizes the snow level setup of ForecastBuilder, a description of that Analyze and Adjust GUI is discussed at the end of this presentation. Otherwise, thank you for watching this training video on the Analyze and Adjust step of ForecastBuilder. Now, for those that have stuck around, let's talk about the Recalculate Pop from Pop 12 button. Let's say we're expecting a decaying MCS to move into the northwest corner of the forecast area. Shown is what was initially populated for both the Pop 12 grids and the floating 3-hourly grids from 0Z through 6Z. Now you agree with the spatial coverage of the pops, but you think the magnitudes are a little too low for your liking. An easy way to fix this is to go to the Pop 12 grid and, using whatever method you prefer, adjust the grid so that it better represents what you believe the max pop value should be after collaborating with the surrounding offices. Once you have your Pop 12 grid done, simply select the Recalculate Pop from Pop 12 button, and you'll see it turn green, showing that it is finished. If you cycle back through the 3-hourly pops, you'll see that the magnitudes have increased, but the overall spatial pattern has not changed. And where there were no pops, there continue to be no pops. One caveat to this tool is that it cannot be used to add pops where there were none to begin with. Next, we'll discuss the Add Smoke to Sky from Her button. After selecting this button, the following GUI will pop up. Now, before making any changes, you should have looked at the Her smoke model already and gotten an idea of what the vertically integrated smoke concentrations are across your area to get an idea of what values you'll need for this step. You can leave the defaults as is, but after observing smoke on numerous occasions in your CWA, you'll get a better idea of what Her smoke values correlate with sky obscurations in your area, and you can adjust the values as necessary within the highlighted boxes. Next, you can set what you would like the minimum and maximum sky cover values to be for the smoke that you'll be adding. Next, decide what to do with the sky grid if there is no smoke present. You can either choose to keep the current sky grid or set it to a fixed value of your choosing. Most of the time, you'd probably want to use the current sky cover grid. Finally, decide what to do if your current sky grid has a value that's higher than that provided by your smoke adjustment. You can either leave the current grid untouched or set it to the smoke value and hence lower the sky grid value. Again, most of the time you would probably want to leave it as the current grid. Once you make all of your selections, simply hit OK, and you'll see that your sky grids will be repopulated to include the smoke. Now, for those offices that use the snow level setup of ForecastBuilder, this is what your GUI will look like. Under the Analyze and Preview P-Type section, you can preview your weather grid and snow amount grid based on the snow levels. Under the snow level section, the Check TW and Snow Level Consistency button will highlight any grids that have a snow level below ground when the wet bulb temperature is too warm, or when the snow level is above ground but the wet bulb temperature is below freezing. In order to fix these inconsistencies, the Change T to Match Snow Level and Change Snow Level to Match T buttons are provided, and you can select whichever option is needed to fix the inconsistency. As a reminder, at the bottom of the GUI, you can select to use a custom time range if you want to apply a different fix to different time periods. Lastly, under the Snow Amount section, find where TW reduces snow amount, finds where warmer wet bulb temperatures will lead to lower snow amounts. And the lower T to ensure no snow amount reduced button will lower the temperature grid to eliminate the potential reduction in snow amount. This wraps up the Analyze and Adjust section of ForecastBuilder. Thank you for watching this training video, and as always, if you have any questions or feedback, please reach out to the ForecastBuilder team via the VLab site or by email.